Okay, this is Geometry Lesson 1.8. It's a video lesson that supports what we're doing in IXL Lesson C3, which is identifying complementary, supplementary, and vertical angles, and actually also adjacent and congruent angles. Those are treated in this. So you're going to take notes on those in your math notebook, and you're going to also explain how you could use what you learned to solve a problem that you think is similar. Remember that you need to do a header on your notes for every day you submit notes, and that's of course every day or close to it. It's just Wednesdays that we don't do these video lessons most of the time. And so the header is, first you print your name, and then you print the date. Make sure your name, by the way, is first and last. It's printed, and it's legible. The date, the period, and then the subject. And of course the subject is what you see right here, complementary, supplementary, and vertical angles. All right, so you're going to upload those to me through my email by 11:59 p.m. Sunday. We are transitioning this week, just so you know, to Synergy Dropbox. I'll let you know when it's live. Probably I won't get that information to you till Wednesday. So until then, you continue to use the email. And again, my email is joshua.warren@twsd1.org. Okay, so there you have it, and we'll move on to the next page. Okay, so what you're going to do here is you'll be able to identify complementary, supplementary, vertical, congruent, and adjacent angles when you are done with this and with the IXL work that you're going to do. And these are some brief definitions. Complementary angles are two angles that together have an angle measure of 90 degrees. So if I had an angle like this, but I had another one next to it like this, and together they form a 90-degree angle, those are complementary. Complementary angles. Now I'm not going to describe them in detail here. I'm just giving you a quick sketch, but we will describe them in more detail later in this video. Supplementary angles are two angles that together have a measure of 180 degrees. So that would be something like so there's your first angle. Oops, that's an arrow. And here's your second angle. So here these two angles are supplementary angles. Now I'm going to use something that's notation. So I'm going to use this. This is angle notation. And that means angle. I mentioned this in the previous video, but I want to remind you. Over here, you see these marks? This mark here is one arc. This is two arcs. That's also notation. This means one arc here, and this is two arcs. Basically what that means is these angles have two different measures. But together, you'll see they're on one line. So because they're on one line, any angle that by itself is just one line with a dot in it, that's 180 degrees. That's sometimes called a linear angle because it's formed by a line basically. That's what supplementary angles form, 180 degrees. And that's basically here. Okay, vertical angles. They're two angles that share the same endpoint and are mirror images of each other. And so here's the way you usually see them portrayed. So you've got two lines that cross each other. They intersect each other. And here's the common endpoint. We'll call this just, I don't know, we'll call it M for midpoint. Well, let's use E for endpoint, just E for endpoint, because it's the endpoint of each angle, but it's in the middle of the picture. And then this angle here and this angle here are the same measure. So we'll call this one angle A, and this is angle B. Okay. We can use one letter for angles. So typically speaking, well, you know what? I'm going to restate this. So let's do this again. I don't want to confuse you. So let's say that there's a point here that's A. This point is B. This point is C. And there's a point here that's D. And this is B again, and this is E. Okay. So these two angles are vertical angles. And we would describe them in notation form as, over here, this one here is angle ABC, and this one over here is, so this is vertical angle ABC, and the other one on the other side is vertical angle, and then it's DBE. Okay, so these are rough sketches, and because this is a video, you can start it and stop and go back and forth, but you can see them all. And so now we're going to go on and I'm going to show you what adjacent angles are. So those are two angles that share the same endpoint, but they also share an angle side. So let's just say I've got so here you've got two different angles. Now, they aren't meant to be the same measure. They're just two angles. That's the way I want to think about it. And so you'll notice they share an adjacent side. This is the adjacent side. So we'll call this, let's see, we'll call this E over here for endpoint. Notice they both share the same endpoint. So E is the vertex of these two angles. And so let's call this A, we'll call this B, we'll call this C. So now we can say here that, okay, this is the adjacent side. And so we call that adjacent side ray BE. So ray BE, its notation looks like this, because that's for a ray, and then BE. And so that is the adjacent side. And then, like we said, E is the vertex. Okay. And so, for what it's worth, this is angle AEB. So we call this one angle AEB, and this one down here is angle BEC. You always put the vertex letter in the middle of these three letters. Okay. All right. Now, I'm showing these to you. I'm identifying these angles by three letters. It's the common way of doing them. But there is a time when you identify angles by number, in which case it's angle number 1. And usually they put it inside between the two rays of the angle. Or they might even label it A, B, or C, you know, or some other letter, and put it in the middle. But that's the only time you'll see that. Now, congruent angles are two angles that have the same measure. So, again, a good example of that would be, again, vertical angles, of which these two, and I'm not going to identify them here, are congruent. And the notation for the word congruent is this. So it's an equal sign with this tilde mark, this wavy mark on the top. That's the congruent symbol. Okay? And you would use that in geometry to replace equals. So it means the same as, the same measure. Okay? All right. Now, now we're going to go to the actual examples of the pictures. So they want to know here what angles are, whatever the type of angle is. So it says what angles are complementary to each other in this first example. So I'm looking at this and I say complementary means that they are together 90 degrees. So if you look at this, two angles that are complementary, we could pick several out, but I'm going to show you one. So angle AGB and angle FGA are complementary. Now in IXL they're only going to ask you for just one set of these, but if you look down here at the bottom you can say also angle, let's see, EGD and angle let's see, DGC are complementary. And that means, again, complementary angles measure together 90 degrees. Now, how do I know that these two measure 90 degrees? Because I notice that angle FGE is 90 degrees. And if you look at it's this ray from this side, this part of the angle going all the way across, and this line that goes all the way across, a line BE, and this line FC, which its rays are part of this, form four 90 degree angles. So this is a 90 degree angle, this is a 90 degree angle, and this is also a 90 degree angle. So whenever you see one of them in an intersection like this, you know they all are, and it's because of the vertical angle. You think about it, vertical angles are congruent. So this angle here, that's the right angle that we've identified, is congruent to G, and since we know that each of those is 90 and the whole thing has to be 360, these two have to be 90 as well. So those are things that you need to be able to prove, and I just proved it by using vertical angles. Okay, that's beyond really what we're doing today. Today we're just trying to identify what's complementary in this case. All right. So then the next one looks a little more complex. Now here I actually give you 4 possibilities, and so you're going to pick one of these 4. So the obvious thing is there could be more possibilities here. So which angles are supplementary to each other? So remember, supplementary angles or supplementary pairs of angles measure 180 degrees. So the easiest way to do this is to look at the different answers and see, would they equal 180 degrees? So they say here, first of all, angle 7 and angle 16 are supplementary. So let you check it. Angle 7 is down here and angle 16 is here. Well, okay. I'm going to tell you, if this line up here were parallel to this line here, it would indeed be true that these two are supplementary, because each of their intersections would form 90 degree angles, and so we would be able to make that determination. But these two lines, it's obvious to see that they aren't parallel. If they extend down to the right, eventually they will intersect. So the next 2 and 13, so here's angle 2, and here is angle 13. Same problem. If you turn it this way, you can see these two lines are not parallel. So those two sets aren't correct. Let's try 13 and 14. Okay, here's 13 and 14. Now 13 and 14 share a side. They share the side between them, right? And then the other side forms a line. So this is, if you were to take a protractor and put it on there, you form this one arc that's against this line. So this is a linear pair. It's what we call linear pair, and linear pairs are supplementary. So this is your pair of supplementary angles. And then 9 and 2, look at 9 and 2, where's 2? Here's 2, and here's 9. Again, same problem as before. We had these two lines that are going through them, which we call transversals, are not parallel. You can only make supplementary angles out of those if the lines are parallel, the transversal lines. We'll talk about transversals later. Okay, so that gives you this one. And remember, we're just trying to identify this stuff. So, all these extra little rules that I'm talking about on the side, you're going to learn more about that. That's not going to be part of the test at this point. You just need to identify them. Okay, so which angle is vertical to angle 2? Well, here's angle 2, and angle 2 is, remember, is the mirror image of its other vertical angle. So if you were to take this angle and you were to flop it across, directly across, we would find that angle 5, let's put it up here, has got to be the other vertical angle. And notice the intersecting lines, they share the same intersecting lines. So angle 5 is vertical to angle 2. Okay. All right. So that takes care of vertical angles. And see, supplementary angles. Oh, I'm sorry. This is adjacent angles. Adjacent angles. And this is, we're almost done. So adjacent angles, if you remember, they share a side. So where's it says which angle is adjacent to angle 1? Well, here's angle 1. And notice its side on the left here, it shares with angle 2. So they're adjacent angles. On the other side, it's adjacent, it shares this side with angle 6. So those are also adjacent. So looking through this, I don't see angle 2. So here's angle 6. Here's the obvious answer. Okay, so that one's pretty easy. Okay. All right. Last one. Which angle is congruent to angle E? Yes. Question? Okay, I guess not. So I was talking to a student on the side. Sorry about that. Which angle is congruent to EFP? EFB, angle EFB. So EFB is EFB. It's this angle here. They want to know what's congruent to it. Well, why don't you look for an extension of ray EF, and it extends out to C here. So that's the whole line. And then the side B here, it's from B to F, that ray extends on to D to form a line. So obviously the two lines that we're working with are this line and this line, right? And so then that means then that this is your other vertical angle, and so that's CFD. So angle CFD is congruent. We'll use the congruent symbol to angle EFB. Now I did something, and I didn't do it on purpose, but it makes a good lesson. This angle EFB is, you read it EFB, in other words, from right to left. And if that's the way they name it, then we're supposed to name the other angle from right to left. So that would be DFC. So I'm going to change this and reverse it to DFC. I had the letters in reverse, the way they had set it up. Okay, so that is everything here. Now I will say about this one, yes, these are also vertical angles. So be aware of that. You're dealing with vertical angles. The other two vertical angles are here and here. There are always two sets of vertical angles in an intersection. But we're talking about, of course, the ones that you see here. So vertical angles are congruent, and that's something that you will want to remember. All right, we are done. So I'm going to go ahead and stop this now, and you will go on to your IXL lesson on this subject, which is lesson C3.